Good afternoon, class. Today we're going to be looking at functions.
This is, well, I'm not going to say new to the world, but a new topic. We've looked at graphing lines and circles.
A new topic for the class.
Yes.
Okay.
So it's something we haven't mentioned yet this semester. And so I think I'll begin by defining what we mean by the word function in algebra. And there's a few definitions. Here's the most basic.
General definition.
Yeah, most basic general definition. A function is a rule which assigns to each x value, I can either say one and only one or just exactly one, y value.
When you think of x and y, what do you think? X and y. If I think of x and y, I think of an ordered pair.
And the graph. So we're going to give a name to the set of x values. The set of x values we'll call domain, and the set of y values we'll call the range. Okay. Set of x values the domain, the set of y values the range. And I think that's enough to start looking at problem number 1.
Let's see. I did pretty good the last time without you, Tony. Only one time did I make a major, was writing, and they didn't warn me I had it switched. There was only one of those major mishaps. I wrote and forgot to switch it over for y'all to see what I was writing.
I'm trying to... It says determine whether this correspondence is a function. So they're using the word correspondence the way I'll use the word rule in my definition. So
look at that first arrow. It looks like the number 17 in the domain is being assigned to 1 in the range. 23 is being assigned to 11. What's 8 being assigned to? 1.
So how many numbers with a function, each x value can only be assigned one y value? So how many numbers is number 17 being assigned? Let me look at
Switch to the page.
Yeah, go ahead and switch. See here, number 17 just has one y value assigned. The number 23 has one y value. The number 8, one y value. Is this a function? Is each x value getting only one y value? Yes. So this is a function. Yes, it is a function. Why don't you? And
a moment ago I was talking about ordered pairs. Do y'all see what ordered pairs would be generated by this little diagram here? The x value would be 17, the y value is 1. So hopefully you could write out 3 ordered pairs that are being generated by that diagram.
But it's a good idea to ask yourself, what would need to be here for it to not be a function? Look back at my notebook, Tim.
That's a good question.
What would it need to... okay. Notice how each one of these numbers has just one arrow coming out of it. Suppose I did this. Suppose there were 2 arrows coming out from the 8. Would it be a function then? No, it would not be a function, because then this x value has 2 y values. So here for this little red line, I'm going to write not a function. If any one of those numbers had 2 arrows coming out of them, then there wouldn't be a function. But for us, there wasn't that case, and it is a function.
Let's look at number 2. They can't all stay that easy, can they?
Let's see.
Here they are written out as ordered pairs.
Yeah. Let me write it out. The ordered pair 2, 3, 28, negative 6, 32, 3, 2, 1, and 46, 1. So
They want us to determine the domain and range and tell whether it's a function.
first thing we're doing is finding the domain.
And when you're listing out the domain, my math lab already has the set brackets for you. So you're not going to have to type those, you see. They already have the little set brackets there. All you're going to do is type the numbers, and they want it separated by a comma. And notice it says, write each answer only once. So if a number is used, if a number appears twice in the domain, you do not write it more than once. So,
No. Domain, those are the x values. So, 2, what's the next x value? 28, 32. Okay, don't list the 2 again. It's already been listed once. And then 46. So let me go ahead and write domain and range, and then you can type those in. Range. Same instructions, don't repeat, write them only once. What are the y values here? 3, and then what? Negative 6, 1.
so let's type those in.
2,
2, comma, 28,
comma,
32, don't forget the commas.
46.
Okay. And the range.
3, negative 6, 1. Okay. Now it's going to ask, is this relation? Notice they're using the word relation the way I used rule. Okay. So they've used correspondence or relation.
A relation is just a set of ordered pairs, what we call a rule.
I like these arrows up here. If there's 2 arrows coming out of the same number, it's not a function. If I started drawing the arrows here like 2, 3, 28, negative 6, 32, 3, so far each number has only 1 arrow coming out of it. What's about to happen when I draw the next arrow? Yeah, 2 arrows coming out of number 2. So we can answer the question right now. Not a function. Do y'all see why? This x value has 2 y values assigned to it. This x value has 2 y values assigned to it. So, could y'all figure out a way just to look at this and decide it's not a function without drawing out this stuff? How could you look at this and tell, hey, it's not a function?
Just look for repeated x values.
So-
There's a repeated x value.
Let me say. Here's another way you might see function defined. A function is a list of ordered pairs in which no x values are repeated. If you have 2 of the same x values, it's not a function. So you could look at this and say, not a function, Because the x's are repeated, right? Or the number
Realize
2.
it's perfectly fine to have repeated y values. The 3 and the 3, that's fine. You just can't have repeated x values.
Let me make a note of that. Repeated x's, not a function. What about repeated y's?
That's okay.
Yeah, that's
Provided
fine.
there's no repeated x's also, then
The repeated x's. The reason this thing is not a function is because of the repeated 2's. The repeated 1 has nothing to do with it. Y'all see what I mean by repeated y's are okay? It's not the fact that the repeated y there. It's the fact that there's repeated x's. Now, with that idea of no repeated x values, we've been graphing. Let's think about a graph, and I have a question for you. Here's a question. Are circles functions? And that's right. No, okay. I didn't expect that to be so fast. Okay. But let's think about why that would be. If I
draw
drew
a circle centered at the origin.
Yeah, that's what I'm doing. If I drew an XY axis and drew a circle, I'm going to try to draw it with radius 2. Oh, just pretend it's a circle, okay? By that I mean it's just really going to be sort of a curved thing. I'm not using a compass to draw it or anything. There. So pretend that's a circle centered at the origin with a radius of 2. Are there any, if we started listing out ordered pairs, are there any repeated x's? Because if there's repeated x's, then it's not a function. If I look right here at this point, could y'all write out that ordered pair? What would it be? Be 0, 2. And what about right here? 0, negative 2. See, here's 2 ordered pairs with the same x value. Repeated x is not a function. Now, is there really anything special about right there? What if I looked at 1? If I drew a little vertical line here, then this point would have 1 as the x value, and this one here would have 1 as the x value. So once again, repeated x's. In general, there's something called the vertical line test. This is how you can look at a graph and decide if it's a function. If a vertical line intersects a graph more than once.
No, in 2 or more places.
Wait.
I'd say in 2 or more.
Oh, okay. I was going to say more than once, but okay. In 2 or more places, let's say points, the graph is not a function. Is it clear why that is? I'll draw my little circle. If I started drawing vertical lines, notice how it's intersecting in 2 points. If it intersects in more than 1 point, then it's not a function, because here's 2 points with the same x coordinate. Okay? So what about that problem number 3 that you showed a moment ago? It looked like a V-shaped figure. It asks, okay, well, I guess I don't need to really write this one down. Is this thing a function? Yes, it is. Do y'all see vertical lines intersecting it? All those little grid lines? So,
none of them intersect in 2 or more spots, so it is a function.
Any sort of V-shaped figure like that, if you drew vertical lines, any sort of V-shaped figure, if you drew vertical lines, it's only going to intersect it once. Now, what about number 4? Oh wait, so 3 was a function. Now number 4, that almost looks more like my circle.
I was thinking that.
It's sort of a flattened circle.
It's an oval, probably an ellipse.
So what are we thinking here? Is this a function?
No.
And could y'all tell me 2 ordered pairs that have the same x value? What about right there at the y-axis?
That would be...
Is that 0, 4? And what about
here?
Negative 4. So not a function. You know what? Why don't we just do this?
Decide whether the relation defined by the graph to the right defines a function and give the domain and range. Notice you have a slanted line. This is important because we're going to be able to come up with a generalization regarding slanted lines. All slanted lines have this, with any slanted line would have the same answer to this question. So
are slanted lines functions? Yes. Do y'all see why? With a slanted line, you can draw as many vertical lines as you want, but it'll never intersect it more than once. It only intersects once. So I sort of drew my slanted line to sort of look like the one on problem 4, but this is true for any slanted line. If it's a slanted line, yes. Wait, are slanted lines functions? Yes. Now,
what the domain of range also.
Now, this gets a little tricky. I'm going to go ahead and at the arrows here, I'm going to label them negative infinity to infinity, and here the arrow going down would be negative infinity, the arrow going up infinity. When it's asking for the domain of a graph, you're looking at the x values. If I continue drawing this line out, it's going to keep going left and right forever. Y'all agree with that? It's going to keep going left and right forever. So it'll sure span negative infinity to positive infinity. Anytime this semester you're ever told to write the domain of a slanted line, you're going to have one answer. Negative infinity to positive infinity.
Any real number will be used as an x value on that line.
Because it's going to keep going left and right forever.
What about the range?
Range?
Apply that same logic to the
But instead of left, right, it's going to be
up and down.
Will this go all the way down to negative infinity and up to positive infinity? So if someone said, say something algebraic today, you can say, the domain and range of any slanted line are negative infinity to positive infinity. Okay?
I better put an answer. So we decided, yes, it was, and it doesn't matter, even if that line had been rising from left to right. It would have been going like that, as long as it's a slanted line.
Any slanted line.
And Notice they're telling you use interval notation. So for the domain, left parenthesis, negative infinity, comma, infinity, right parenthesis.
Just went to the Pewson workshop and they
Negative
asked,
infinity.
is there anything we could do to make it better? And I told them, make a hot button that says parentheses, negative infinity, comma, infinity, close parentheses. And they just looked at me. I
Well,
could tell they were
actually-
thinking, that idiot.
One of the people laughed.
Yeah, okay. But by the end of the semester, you have no idea how many times this semester you're going to be typing parentheses, negative infinity, comma, infinity, parentheses. Before the semester's over, you'll see why. Oh, wow, just one little button, there it is. Okay? Oh, look at this one.
What do y'all think? Is this the graph of a function? No?
Doing a very poor job of drawing it out.
That's at negative 2.
Well, heck, I don't need to draw vertical lines. There's already one drawn. Well, for y'all, there's a whole lot of them, right? You
So,
see all those vertical
lines.
lines?
A vertical line can hit it in 2 or more spots, so no, it's not a function.
Show my little picture where I actually drew the function.
Oh, okay.
I mean, drew the vertical
I'm
lines.
going to check this first.
Okay. So not a function.
Move it up. Move it up.
Oh, yeah. Not a function. Now, for the domain and range,
You need we need to look at the actual picture they
Yes.
gave us.
for the
Okay.
domain, we're looking at the x values and the range, the y values.
Where did it go? There it is.
If we kept drawing these blue arrows out, it's going to keep going up and down. But it's not going left at all, is it?
It's still going right. It keeps going to the right forever, right? But it's not going to the left and right forever. So it's not going to be negative infinity to positive infinity.
Oh, I don't know if I like blowing it up like that.
I think I do.
Oh, okay. So I'm trying to figure out what's the smallest x value. There's no negative 10 or negative infinity x value. Say it again. Negative 2.
Negative 2 is the smallest x value. Is negative 2 actually used? Yeah, it's
Yes.
right there at that point. So the domain is going to include negative 2. The smallest x value is negative 2, but we want to include negative 2. So what are we going to put in front? What symbol includes the endpoint? Parentheses or brackets?
Bracket. Negative 2.
Comma, and what did y'all say? Is it ever going to stop on the right? No, so it's going to be a positive infinity. Or what always goes after a positive infinity? Oh, a parenthesis. Now, what about the range? Does it keep going up and up forever? Yes,
Yeah.
this thing
It
does
looks.
right there.
One time I remember a student telling me, "No, I think it's going to start. It's going to turn around." And I said, "No, don't assume that." In the other graph right here looks. It makes it more obvious. It's still going up and down. Okay.
So it's not. There's nothing to indicate it's slanted upward, slowly going up. It's slanted downward, slowly going down. So what do we say about the range? Oh, wait. There.
Negative infinity to positive infinity. This means it's going down forever and up forever. For the for the domain, it starts at negative 2 and the graph is continuing to go to the right forever. Okay? This is some nice graph theory we're doing here. Any questions on that?
I better type it in. Okay. Bracket. Should I shrink it down? Infinity.
Here, just hit that little magic button that types in parentheses negative infinity, comma. Oh, they don't have that.
But that would be nice. But I don't think they do.
Yeah, I don't think they
What's number
do.
7?
Oh,
Okay. How about I take over some now?
okay.
I'm going to have to talk some.
Okay, I'll give you the microphone.
Okay. Okay, I want to talk about something called function notation. Okay, function notation. Function notation is nice because if it's used in an equation, that's telling you that the equation is a function. You wouldn't use function notation to write something like a circle because a circle isn't a function.
I'm showing them what function notation looks like.
Okay.
What formula looking
If an equation is a function, we can, provided the equation is solved for y. To use function notation, the equation must be solved for y. And then in that event, you can replace y with f left parentheses x right parentheses. So basically, y is equal to f of x. F of x is just a fancy way of saying the variable y. And let me make a note. This is read as f of x or function of x. That's what the f stands for.
But it does not mean time.
That is not f times x.
Function
Of x. That means for any given x, there's one and only one y value. And this function notation gives us a nice way to evaluate functions. Instead of, let's suppose I had the function y equals, I'm going to make up an example. F of x equals, let's say, 5x squared plus 2x minus 1. If I wanted to know what is the y value equal when all of those x's are replaced with the number 0, that's the question. What is y equal when every x is replaced with 0? I could just say find f of 0. Find f of 0. Whatever's in the parentheses, you have to go through the equation, and everywhere you see the variable x, you're going to replace it with that number. So we're going to have f of 0 is equal to 5, replace the variable, plus 2, replace the variable, and simplify. Remember, in your order of operations, you square the 0. 0 squared is 0, times 5 is, plus 2 times 0 is 0, minus 1 gives me a y value of negative 1. So when x is 0, the y value is negative 1. We just generated an ordered pair. When x is 0, the y value is negative 1. Suppose I wanted us to find f of 3. F of 3. That says, go through, everywhere you see a variable, replace that x with
3. Okay.
Whatever's in the parentheses, that's what you're going to plug in for x.
Well, 3 squared, you do your exponentiation first. 3 squared is 9, times 5 is 45, plus here, 2 times 3 is 6, minus 1. What's that going to give us? 50. So this function here is just generating ordered pairs. You tell me the x value you want to plug in, I'll plug it in, and that'll give me the y value. Any questions there? For function notation, you go to the function and you replace every variable with whatever's in the parentheses. I have one more example I'm going to make up, then we'll look at homework, okay? F of n. F of n. That says go to your function f, and wherever you see a variable, you replace it with n. It's just a change of variables. All you're doing is just changing the letter. 5n squared plus 2 times n minus 1. And realize that letter, that name F, really you can use any letter you want to name the function. In my business calculus class, I use C of X all the time for cost functions. I use P of X for profit functions. I use R of X for revenue functions. The most common letter, I suppose, to name a function is F, just because the word function starts with the letter F. But you could use any letter you want to, really. Let's look at number, what is it?
Number 7.
Okay, well...
Oh no,
that's why.
Okay.
I guess I'd seen that. Okay, that's where I came up with the 5x squared and the 2x without me even realizing it. So this is number 7.
They might be able to tell me the answer to this one. Find f of 0. If you plug the 0 in for x, you're just going to get 0, right?
Mm-hmm.
I think there's several parts here. Let me see. Yeah, there's 3 parts. Now.
Okay.
Let's do that one. Find f of negative 1. That's going to take me a while.
So
There. So
that says go to your function f, and wherever you see a variable, plug in
negative 1.
negative 1. Okay. I was waiting for the students to answer, Tony. I suspected you knew the answer, but okay. Remember, in the order of operations, what do we do first? Okay, negative 1 times negative 1 is a positive 1. Times 5 gives me 5. What about this positive 2 times a negative 1? 5 minus 2 gives me a y value of 3. When x is negative 1, the y value is 3.
If we were going to be drawing the little thing with arrows, we would have negative 1, arrow 3. Okay.
Oh, it's minus 2x or plus 2x.
Oh,
Tim. Oh, no. Oh, goodness.
Look at that. He miscopied the problem. That should be a
That's the way I
minus.
made that the plus, the one I was making up. Okay, thanks for pointing that out. So what's that going to happen? Negative 2 times negative 1,
Plus 2.
a plus 2. So what are we going to have as our answer? 7. Good.
Fortunately, there's one more for you to do, and let's see if you can get it right.
Did you type in
I'm
7?
going to put in 7 right now. Don't be quiet. Don't help him. Find f of 2, Tim.
Okay, that says go to my function f, and wherever I see a variable, I'm going to plug in.
The red 2, they're not helping you, Tim. And do y'all see the significance of this order of operations? You square first, then multiply. You don't multiply first and then square. You get completely the wrong answer. Okay, so
2 squared is 4, times 5 is 20. Minus 2 times a positive 2 gives me, to give us a y value of, 20 minus 4 gives me a y value of 16. So when x is 2, the y value is 16.
okay, there's quite a few of these. Let's see.
How many parts are on this
Oh,
one?
5.
5.
But I think the first one we can do without any writing. Notice it says for the function k. For
I
some
told
reason
them they
they're
could
using
use
K
different letters.
instead of f, so don't let that worry you. Could y'all plug the 0 in without showing any work and get the answer? What's it going to be? 9, okay. The next one will be hard.
Okay, we want k of negative 11.
I'll plug in the negative 11 for x. What would we get? Negative 2? That sounds right.
Negative 11 plus 9 gives me a y coordinate of negative 2. Realize we're creating ordered pairs. We just created the ordered pair. When x is negative 11, y is negative 2. These equations are creating ordered pairs.
Now let's see. Hey, I bet we can do this one without writing it. Plug the negative 2 in, and what are we going to get? 7? Y'all agree? Oh, well, heck. I'm not going to insult y'all. Y'all can add 14 plus 9. I was about to say, maybe you need to write this one down. But no, we'll wait to write one down till it gets tougher. If you plug 14 in for x, 14 plus 9 is 23. Okay, now here's one for you to do. Find k of c plus 11. And you might be thinking, oh wow, that looks really hard.
No,
Remember
we're
what
not
we said
thinking
earlier?
that.
Whatever's in the parentheses, you plug in for x.
So you come up here to the x, you replace it with c plus 11. We also have what stuck on there? Plus 9, to give us a final answer of, well, we can't combine the c with anything, but the 11 plus 9, isn't that a plus 20? For a final answer of c plus 20.
So whatever's in the parentheses, you plug it in for x. So c plus 20. C plus, oops, I nearly hit 30. C plus 20.
Oh, more of these. Okay, number 9.
We call it f.
Okay, so f of x is equal to 6 times x. And they want us to find f of negative 17, f of 6, and f of 27. I'm going to write them all down. F of negative 17, f of 6, and f of 27. Okay.
Okay.
F of negative 17. We go to our function f. Wherever we see a variable, we replace it with negative 17. So you have 6 times negative 17. Is that going to be a negative 102? Is my mental arithmetic correct?
I was going to punch it in my calculator. Oh, 6 times. Oh, what's going on? It's not working.
Well, I think it's...
Right, that's right.
Is it right? It's right. Okay. 6, replace my x with, to give me. And finally, I go to my function f. I'll replace any variable I see with. Uh, 6 times 27. Is that a 162? Someone check me there.
Yeah, it's 42 plus 120, 162, and you wrote 8.
Oh. Did I say the correct thing and just wrote the wrong thing, or what?
You said 162, but I might have just heard. Never type in B speed. Negative 102. Oops. Still working on my calculator. Negative 102. 36 and
162 moved down.
Are y'all caught up?
Any questions?
Is this one easy or hard? Do we need to write down anything, or can we just type in the answer? What am I going to do? I'm going to replace the x with p. It's just a negative 3p plus 5.
So change a variable, that's all it is.
Oh. Okay, now this one we better write down something. Problem 11. F of x is negative 5x plus 6. And look at what it says to find. F of 4m minus 5.
Negative 5x plus 6.
Write it down correctly.
Okay. This says, go to your function f, and wherever you see a variable, you're going to replace it with 4m minus 5. We have that negative 5 there in front of it. So we're going to have to multiply that negative 5 by that whole 4m minus 5. So, oops. What are we going to do? We take negative 5. We're going to have to multiply that negative 5 by 4m minus 5. And what else do I have stuck on there? A plus 6. What are we going to have to do to perform this multiplication here? Starts with a D. Distribute to give me, here, negative 20m. Okay, negative 5 times negative 5. That gives me that plus 25. And I still have a plus 6. What's that going to give me for a final answer? I agree.
Negative 20m plus 31. Type that in. Negative 20m plus 31.
Any questions there?
Right here on number 9, x is the number in the parentheses, y is the answer. X
y. X, y. Looking at number 12, it better have something to do with x and y, or it would be strange that I mentioned that. On this one, is there any work to it? By that I mean scribble, scribble, scribble. Well, really not. You could write it down, but all you're going to do is write it down and write out the answer. The number in the parentheses, is that x or y? X. Your answer is what? X or y? So here's x. What's y? Okay, look at the ordered pair where x is -5. The y value is -1. This notation here is just shorthand notation for saying find y on the ordered pair where x is -5. Okay?
Is that it? There's not another?
Yeah, that's it. It can't all be that short. Any questions on that? The number in the parentheses is x. Your answer is y. Remember the semester once, I spent about 30 or 40 minutes. Students had so much trouble with it. And then I had the students, how do I do it without the graph? I don't want to, oh God. I was like, what is happening here?
Well, we know how to evaluate functions when you don't have a graph. If you have an equation, you plug in. If you have ordered pairs, you look at the ordered pair, find the x value you want. The y value is the value of the function. There are three ways of expressing functions that we've seen: listing ordered pairs, equations, and we saw it as a graph. Remember those graphs we were looking at using the vertical line test? Is this a function or not? So, here's a graph. We're representing the function using a graph. And do you agree that this equation is a function? Let me ask you something. If we stated the domain and range, do they keep going and going forever to the left, right, up, or down? Do you see any arrowheads? No? So, if we were to state the domain and range, would we have any infinities or negative infinities? No. Okay, but that's beside the point.
I think that's what I'm going to do about that.
Looking at part A, we want f of -2. The x value is -2. What's the y value when x is -2? 0. When x is -2, the y value is 0. I agree. But there's no work to show there other than just looking at reading the graph. F of 0. When x is 0, what's the y value? 4. Right there, that point. When x is 0, the y value is 4. 3. Can we tell?
Oh.
If we're going to do that, we got to. Yes, we can.
Okay.
I was expecting it to
3.
be 2. Okay, but it
You
says
thought they were going to ask find f of 2.
f of 2. Yeah.
So what would f of 3 be? It's at 2 right here where my little cursor is. Is that what it would be?
Mm-hmm.
So 2. And finally find f of 4. Here's the x value, 4. What's the y value there? 4. Semester where students had so much trouble with this. I remember one student made up a rule. So the last one, it's always going to be the same answer here and here. I was like, nope, that's not what you're supposed to be getting out of this.
The teacher was
doing a very poor job. Yeah. Okay, you're right. The teacher was doing a very poor job. Hey, what's f of 1? Could y'all tell? What's f of 1? Here's 1. Would be, is it 2? Okay. Any questions?
If you're analyzing graphs and determining y coordinates, they got to make sure that they're numbers that you can spot, okay? But they couldn't ask you with this graph, what's f of 2.347? Well, 2.347 would be somewhere right out there, I guess.
So it'd be a little bit bigger than 1, but you wouldn't be able to tell the exact value.
I think you moved your cursor.
Oh, well,
Anyway.
it'd be around 1, but you
Hey,
could.
here's a good question. What's the domain here? It's not negative infinity to positive
That is a good
All of
question.
the x values are between what two numbers? I'll get you started. -2 and 4. So the domain is -2 to 4.
Parentheses or brackets. Bracket,
Bracket.
because we're using them. What about the y values? It's not a negative infinity or positive infinity. What's the smallest y value on that graph? 0, and the biggest is 4. So bracket 0, comma 4 bracket.
Now, it's pretty easy to figure out the domain if you're looking at a graph, or if it's like problem number...
Go to the previous one where they had ordered
number
pairs.
2. Oh, yeah, you're right. Here was one I was thinking of, what specifically said, what's the domain, what's the range. But you're right. On problem number 12, if it said find the domain, what would it be? -5, 2, and -2. The range would be just as easy, -1, -5, -4. The natural question to ask, and I'm sure y'all are dying to know, if the function's written like this, as either a formula or an equation, how do we find the domain? And that's what he's about to tell you. For the rest of the problems, just scanning through, you're going to have these little formulas, and it's going to say, what's the domain? Some of them are multiple choice, but then it stops, and not all of them are multiple choice. 2 of them are not multiple choice. So let's go back to number 14, but you're going to first...
I have to write some.
Yeah, write some. Tell them how to find that domain.
Okay. To find the domain, of a function written as an algebraic equation, I'm going to put colons there. I'm not going to have that. Oh, goodness. There. I guess in the future, next semester, this video will go into my online COVREC class. And so this won't apply to those people in the future watching the video. But right now, aren't allergies really bad? I forgot to take my Nasonex this morning, so, oh goodness, so forgive me if I start sneezing. I'm going to cover up my face, and I'm sorry about that. Turn that off. I forgot to silence my phone. To find the domain of a function that's written as an algebraic equation, f of x equals something like that. Unless we're told otherwise, we're going to assume that the domain of a function is the set of all real numbers that you can plug in for x to produce another real number. So, unless told otherwise, and you say, when are you told otherwise? In my business calculus class, students are always being told this function, it only works for a production level of 1,000 units or more. So the domain is 1,000 or more, but unless told otherwise, assume the domain of a function is the set of all real numbers comma, that when, but I'm not going to write out plugged in for x. I'll say that when substituted for x, is the set of all real numbers that when substituted for x produces a real number for y. Now I'm going to stop and make a parenthetical remark right here. There have been 2 times this semester when we were working with numbers and the thing we got was not a real number. So you want to avoid. Yes, that was the second homework assignment. You don't want to get an imaginary y value. Remember, these ordered pairs should be able to be labeled on an XY grid. You can't label an imaginary number on an XY grid, so you want to avoid imaginary numbers. And there was another time. It involved division. When you had numbers, you were working with numbers, and the thing you got wasn't a real number. It was undefined. You want to avoid denominators of 0. The 2 things you want to avoid producing. I'm going to write it out later. I'm a briefer. Here's what you want to avoid. You want to avoid the square root of a negative number. If you get a y value that's an imaginary number, then that x value that you plugged in is not in the domain. The other thing you want to avoid, it's a fraction, a number divided by 0. Remember, that says no. Those are the 2 things you want to avoid. Now, let's go. Well, let me give him a moment. I wrote a lot there. So, let's look at number 14. We're not going to write out the answer yet. I just want to look at it. You see that there's a fraction. Well, that thing could produce undefined results. Yes, since there's a fraction, you could get a denominator of 0. Could you get a square root of a negative? In order to get an imaginary number, to get a negative number under a square root, what has to appear within the problem? A square root. You have to have a square root in order to get imaginary numbers. Look at number 15. We'll go on to number 16. Okay, this could produce denominators of 0. We'll have to prevent that, but will it produce imaginary numbers? No, because there's no square root once again. I know there's one with a square root. That's the thing that you want to avoid, that you have to be careful of, because it could produce imaginary y values. But the things you want to avoid, denominators of 0 and square roots of negatives. Look at, and in order to get an imaginary number produced, your equation must contain what symbol?
Square root.
Okay.
So,
the problems occur when you have square roots appearing and fractions appearing. Well, suppose your function has no square roots appearing and no fractions appearing. Then, suppose you have no fractions and no square roots. Unless you're told otherwise, look at that example that we were just looking at. And once again, no, go to the next one. There. It doesn't matter what you plug in here on number 15. Let's write out number 15, okay? Number 15. X squared minus 13x minus 7. And we want the domain. What numbers can you plug in for x and get a real number back for y? Switch to my paper.
Am I going to pick up any imaginary numbers? No, because my function doesn't contain what? In order to get the square root of a negative, your function must have what symbol? A square root. I don't see a square root, so we don't have to worry about imaginary numbers popping up. Can we get an undefined result? This reminds me of those denominator cut points. That was when we first started looking at that denominator of 0. If this were an inequality, say it said greater than 50 or something, would you have any denominator cut points? In order to have the denominator of 0, your function must have what symbol appearing? A fraction, if there are no fractions and no square roots, unless you are told otherwise, assume the domain is all real numbers. Negative infinity to positive infinity.
You can plug any number you want in for x using a calculator, even if they're big decimal numbers. You'll still get a real number back. You won't get the error message about non-real answers. Isn't that what most of y'all see? If you punch in a square root of a negative, this one says non-real answer error.
What if you put a fraction, a number over 0?
6
what does
divided
it say?
by 0 says non-real, or no, error, divide by 0. You can't divide by 0. So you can plug any number you want and you'll never get either of those two messages. So the domain is all real numbers. There.
Now that's the nice case. That's the one that you see the function, no fractions, no square roots. The domain is all real numbers. Well, suppose there are fractions and square roots. Let's go back to number 14. Find the domain. We want to know what numbers can we plug in for x and get a real number back for y. Not an imaginary number, not an undefined result.
What's the one number you can't plug in? What? A negative 11.
Negative 11. When you're finding the domain of these, a function that's a fraction is called a rational function. So to find the domain of a rational function, a fractional function, what you want to avoid, you don't want the denominator to be 0. It's like finding those denominator cut points. X plus 11 cannot equal 0, so x cannot equal negative 11. Could you plug in 50 million for x? Yes. Could you plug in 7 for x? What's the only number you can't plug in for x? Negative 11. I like to write out the domain in words. In this case, the domain, what numbers can we plug in for x? You can plug in any real number except for negative 11. So I'll say all real numbers except negative 11. But they want us to enter this as using interval notation. So how do we express this? Here's a number line. Here's a number line. There's my infinity. There's my negative infinity. And there's negative 11. We don't want to include negative 11. How do we always label those denominator cut points? Do we shade them in or leave them open? We'd leave them open because shading in means it's okay to use it. It's not okay to use a negative 11 because you get 8 over 0, which isn't a number. But it can be anything over here or here. The only number on that number line that isn't shaded is what? Negative 11. So to express all real numbers except negative 11, you have the
negative infinity to negative 11, parenthesis. What would we put between the intervals when we had more than one interval? A little union, and then parentheses, negative 11 to infinity. Oh, I should have reminded you, you always use parentheses with infinities and negative infinities. You always use parentheses with open circles. The only time you use a bracket is with the closed circle. This interval here says every number to the left of negative 11. This interval says every number to the right of negative 11. The only number not included is negative 11 itself. So this is a fancy way of writing all real numbers except negative 11. Oh, wait,
okay.
It's multiple choice.
Wait, I think there's 4 options, though.
Nope, I don't think. Oh, yeah, there are. Okay.
Well, A, B, C, or D.
Oh, wait, no, not that one. B?
Mm-hmm.
Look, can y'all figure out what's A? It's saying all real numbers except negative 11 and what else? 0. So there's a fancy way if you picture that number line in your head. To the left of negative 11, between negative 11 and 0, to the right of 0. So, probably to the detriment of math education, we've gone so fanatical with this interval notation instead of writing it out in words. All right?
I try not to say that anymore in case Pearson's listening to these videos. We don't want Pearson to get mad at us.
What would they do?
I don't know.
Okay, there's 2 numbers here we can't plug in for x. On the first fraction, what number would give me a 0 in the bottom? 9? What about the second fraction? 4?
Oh, okay, wait a minute. Let me write the problem down.
So in words, we'd say all real numbers except 9 and 4. Well,
okay, let's see, Wade. Let's switch over. We're going to write it out. We don't want, in this case, there are 2 fractions, 2 denominators. We don't want either of those denominators to be 0. So x minus 9 can't equal 0. So x cannot equal 9. X minus 4 can't equal 0. So x can't equal 4. And so if we were writing it out in words, the domain would be all real numbers except for 9 or 4. You can't use 9, you can't use 4. Could you plug in 50 million for x? Yeah, you sure could.
what about 2.4? Could we plug that in?
Mm-hmm.
Yeah, anything except 9 and 4. But we can't write it like that. You've got to write it out in interval notation.
So let's see. Well, think of it. Think of a number line. You don't have to picture it. I'm going to draw it for you.
Oh, okay.
We don't want to use 9 and 4. Do I write 9 here? You have to put them in small to big. And you don't shade them in. If you shade them in, that says you can use them. And we know we can't use those. But it can be anything to the left of 4. Anything between 4 and 9. And anything to the right of 9. If you've written that, if you've drawn out the number line, you can probably, it's it's multiple choice. You can probably pick out the options. But I just feel like the problem isn't finished if I don't write it out, okay? So, here go. Are we going to have any brackets? No, it's all parentheses. So, parentheses, negative infinity, comma, 4. Okay, so that's saying everything to the left of 4, or, parentheses, 4, comma 9, or
Oh, parentheses in front of the 9 and? Okay, good.
So see how he's getting that, because on problem 19 it's going to be like 16, but you're going to have to, it's not multiple choice. When it's multiple choice, yeah, okay. A would be all real numbers except what?
9, they're just avoiding that, they're ignoring that second fraction.
What about this one here? All real numbers except D.
0.
D is 0. And those are wrong answers. Okay? So, if you have fractions, you do not want
Denominators of 0.
0.
Oh, you were waiting for them to.
Well,
Okay.
if you have a square root, you do not want a negative number under there. Is it okay to have a 0 under the square root symbol? Like if I punch in square root of negative 25, it gives me an error. Non-real answer. Okay?
What about the square root of 0? Is that okay?
What's the square root of 0? What times what gives 0? What times itself?
0 times 0. The square root of 0 is 0. I want to look closely at number 17 and number 18. I'm going to write them down, and I want to discuss their differences. Let me write down number 17 first. Oh, you and that purple. Even if it's not good. Okay, so we're finding the domain.
So he's writing down problem 17 and 18.
Let me write down number 18.
Besides the fact that number 18 is multiple choice and 17 isn't.
There's a fundamental difference. There is a fundamental difference in number 17 and number 18, and it's going to determine how we approach it.
Well, how does 17 look physically different from 18? 17, 18.
What is the fundamental difference between... So, okay, switch over where it's written here on the same page.
Okay.
One of them has a fraction, and this one, the square root's in the denominator. Up here, the square root is not in the denominator. It's perfectly fine to have the square root of 0. Would it be okay to have a 0 down here? 1 over the square root of 0? So, since that radical is in the denominator, we can't let this stuff equal 0. It has to be greater than 0. X plus 13 can't equal 0. It just has to be greater than 0. But this one here, that square root's not in a denominator. Now remember, we don't want it to be negative under there. So 21 minus 3x has to be greater than or equal to 0.
Let's see why we have the equal here, but not here. Because we don't want 1 over 0. But it's okay to have a 0 just under a square root.
Oh, and I told y'all that cut point method would just keep popping up. That's why it appears at the end of homework assignments. Whenever we think the assignment isn't long enough and we add in some old material, that cut point method, I really like to stick that stuff there at the end of the assignment, force you to keep thinking about those inequalities because, well, hey, this number 17, is there going to be a denominator cut point on number 17?
Now, why are you even thinking cut points? Because you have a
I should have asked that.
greater than. You're going to have to use cut point method on both of these, but it's going to be easier than any cut points you've done this semester.
Because it's just a linear inequality. You ask yourself, when is 21 minus 3x equal to 0? Well, that's when negative 3x is equal to, move that number over, what am I going to have? Negative 21. And then what do? Divide by -3 to give me x equals 7 for my solution cut point. Equality is allowed, so am I going to label this number with an open circle or a closed circle on the number line? Closed circle, I agree. So there's my number line. There's 7, and it's a closed circle. We expect one side of 7 to make this into a true statement. We expect the other side to make it a false statement. So, what's my favorite number to test? 0 to me is always easiest to plug in. Which side contains 0, to the left or to the right? Left, so I'm going to test 0. (21 minus 3 times 0). Is that greater than or equal to 0?
Definitely not equal.
So that's 21 minus 0. Is that a true statement? Yes. 21 is greater than 0. Y'all seem uncertain. Is that a true statement? Yes. So we shade. I'm sorry about that. I thought, is that my phone? I told you to turn it.
Because,
okay. So what do we assume is going to happen? Hey, suppose you had tried to test a number over here. Suppose you had tried to test something like 8. What would have happened? What do you expect to happen?
Be false.
If you had tested something like 8 or 10, you'd have 21 minus 3 times 8 is 24 is bigger than 0. 21 minus 24, that's a -3 is greater than or equal to 0. True or false? False, so you would have crossed it out. To find the domain of a square root function, you're going to set it up either as the thing under the radical is greater than or equal to 0, or you'll just set it up as the thing under the radical is greater than 0, depending on whether the radical is in the denominator of a fraction or not. If it's in the denominator of a fraction, it can only be greater than 0. If it's not in the denominator of a fraction, then it's okay to have 0 under the square root, in which case greater than or equal to 0. How do we express this shaded interval using interval notation? Because that's the domain. Parentheses, -infinity, comma, 7, bracket. What numbers can you plug in for x here and get a real number back? Well, every 7 and every number to the left of 7.
Could you plug a -20 in?
Could I plug in a -20 for x? Is -20 in this interval? Yes. Could I plug in 10? Could I plug in 10 for x? Is 10 to the left of 7? Have you tried to plug in 10? 21 minus 30. That's a -9. What do we know about the square root of a -9? It's imaginary. You're trying to avoid imaginary y values.
What'd you say?
30.
I'll plug a 10 in for x. 21 minus 3 times 10. He's saying it's going to say error. Is it? Yeah, non-real answer. You're getting an imaginary number. Okay? I think 3i is what you're getting. Okay?
Go ahead and type in the answer.
Oh, yeah.
Before we get timed out.
Oh, yeah.
Oh, it's
No.
that's number 7. I meant 18. Here you have to type it in yourself. Left parentheses, -infinity, comma, 7, right
Bracket.
bracket. Thank you. Now do the one that has that fraction. It's going to be the same steps. So we ask ourselves, using the cut point method, we ask ourselves, when is x plus 13 equal to 0? And we get when x is equal to negative 13. That's my solution cut point, but open or closed? Open because there's no equality. Here's my number line. There's my negative infinity and my positive infinity, and there's my negative 13. You said we'd have it open. What number do y'all want to test? We're going to shade one side, we're going to cross out the other, so what number do y'all want to test? 0. Which interval contains 0? The left interval or the right interval? Right, so we're testing 0. We get 0 plus 13 is greater than 0. True or false? True. So we shade this interval. Suppose we had tested a number over here. Suppose we had said, oh, let's test a number to the left of negative 13. What do we expect to happen?
True or false?
We expect it to be false. But if you said, oh, I'm not sure, let's check. Let's see. How about negative 14? You get negative 14 plus 13 is bigger than 0. Negative 14 plus 13 is? Negative 1 is bigger than 0. True or false? I heard both, true and false. Which one is it? False, so we cross it out. Uh-oh. Let's see. How do we type the domain? Call it out. Here's the domain. Parentheses. Negative 13. Comma. Remember, with the interval notation, it must go small to big, left to right. Up here, negative infinity, and then the larger number 7. Here, negative 13, and then the larger concept of positive infinity.
Before I type that in, I want to show you. If we're saying that you can't plug negative 13 in. That's what this parenthesis means. Can't plug that in. If I plug negative 13 in for x, I'm going to get an error warning. What warning? Am I going to get non-real, imaginary answer, or error divide by 0? You see? So there's two ways you could get an error warning. If you plug negative 13 in for x, or like right here where you tried negative 14, what if we had tried to plug negative 14 in with my calculator? It would be a negative 14 plus 13.
Well, we're not going to get a denominator of 0 here.
What error are we going to get? Non-real answer. Non-real means imaginary. Okay? So what numbers can we plug in? Any number bigger than 13.
Negative 13.
Negative 13. Sorry about that. Okay, so... Oh, this one was a multiple choice. Okay.
I think there's a D option.
Oh, yeah. Oh, wow. That's tricky, isn't it?
Mm-hmm.
You'll see I'm choosing A. Don't include negative 13. What's the difference between A and D? D is saying you could plug negative 13 in for X, and you can't.
Question. It depends where the radical is located. The fact that the square root is in the denominator, we can't have 1 over 0, so x plus 13 can't equal 0. It has to just be greater than 0. So it can't be greater than or equal to.
So if there's a fraction, just greater than. If there's not a fraction, like number 17, greater than, equal to.
Switch over here. I'm going to write one of my... switch to my... Is that what my jacket looks like? All right. Wow, it looks different there on that camera, at least different from how I see it. Okay, I'm going to write radical. I'm going to move it up here. Okay. I'm not going to say radical. I'm going to say square root in denominator.
Greater than 0.
Square root in denominator. You set the radicand greater than 0. The radicand is a fancy word for the step under the radical. So radicand just greater than 0 if the square root is not in the denominator. If it's not in the denominator, it's okay to get a 0 under there. So I'm going to say square root not in denominator. You set the radicand greater than or equal to 0. Any questions there? That was a good question. Need to make sure y'all follow our logic. If the square root's in the denominator, you don't want to wind up with a denominator of 0. So just set the radicand greater than 0. Any other questions there? We're not through. I know there's some more.
One more. This is one of those assignments that doesn't have 15 problems. It had 19.
Okay, this is number 19.
Having done all of that stuff about cut points, do we have to do cut points on this one? Say no.
What is it?
Because there's not what symbol?
The square root. The square root is what says, but I'm going to say radicand, go back to my little page here while I was making the summary, and I'm going to say use cut points. Use cut points. For the square roots, finding domains of square root functions, you have to set up an inequality, and then we'll use cut points on them. But number 19, there's no square root. They want us to find the domain. I'm not sure why they're saying don't use a graphing calculator.
It really wouldn't help.
It wouldn't help.
But I'm not sure what.
Okay.
I claim this one is sort of like number, is it 16?
Yep.
Yeah.
I think it is.
This one was pretty simple to figure out the numbers that you can't use. Okay?
But the denominators were linear, so it was real easy to.
Someone can read my mind and figure out what I'm doing a very poor job of hinting that you should do what to this bottom. Starts with the F. Don't say foil. Factor it.
Okay, switch to the thing. For a fraction, you don't want the denominator to be 0. So, let's try solving by factoring. X squared, that'd be an x times x. This isn't bad at all. What times what will give you 8? I can think of 2 pairs of whole numbers. 1 times 8 and 2 times 4. It's a simple trinomial, so you want the pair that subtracts to give you what number? 2, that negative 2, so what did y'all say about the signs? I didn't ask y'all. One's going to be positive and one's going to be negative. So what's going to go with the positive and what's going to go with the negative in order to get that negative 2x? What's plus 2 and the minus 4? I agree. So set both factors not equal to 0 to give us x cannot equal negative 2 or x cannot equal positive 4.
So what numbers can you plug in for x? Well, any number except negative 2 and positive 4.
So I could write that out in words. The domain all real numbers except -2 or +4.
I don't want it written out in words. So,
We're going to have to write it using interval notation. How do we say that using interval notation? Am I going to have to test intervals here? No, you test intervals with square roots when you're using the cut point. That's when you test intervals. Here's my number line. There's my infinity. There's my negative infinity. I have -2 and +4. How am I going to label those? Open or closed? Open, we don't want to use them. Remember the way we were doing this in number 16? We found the numbers that made the denominators 0, and then you want everything else. You want the numbers to the left of -2, the numbers between -2 and +4, and the numbers to the right of +4. I have to write that out using interval notation. Am I going to have any brackets? No, so it's all going to be parentheses. Parentheses, negative infinity, comma, -2, parentheses. This is saying everything to the left of -2. Or -2, comma 4. We've already said it's all going to be parentheses. Or, oh, by the way, this thing that looks like an ordered pair, it's an open interval saying every number from -2 to +4, not including the endpoints. Or this one, parentheses, 4, comma, infinity, parentheses.
all of that to say all numbers except -2
or
4. Wow.
Wow, yeah. I do believe that, unfortunately, interval notation has a way of hiding what you're actually trying to say. You're trying to say, you can use any number you want to. You can plug in 50 million. The only numbers you can't plug in for X are -2 and +4.
My mother's 96, so is yours. She could read all real numbers except -2, 4. But this, if I asked her, what does this mean? Of course she has no idea, okay? We hide things that could be easily said. We make it even more
Convoluted.
or confusing to students by cloaking it in all this darn interval notation.
Prior to the 90s, interval notation was not stressed as much as it's become nowadays.
I remember, oh no, you don't want to do that. You want it written out in words so people can understand it even if they don't know math. But now I see what was happening. Well, they were already working on this stuff.
The programming.
And they didn't think that they, typing in all real numbers except, that doesn't work in the programming as easily as just having them type in these symbols.
Any questions there? So there's no review material here in this assignment. It's all new material.
And we've begun a new unit over functions, by the way. At this point, every section after this, except for the last lesson, we're going to be dealing with functions. In the very last lesson, we do something different.
But we're beginning functional analysis at this point.
A big old unit over functions. Any questions before I stop recording?
Well, stop recording and then